all. Today we are going to talk about scientific notation. This is something you may have seen before, but maybe not really have a good understanding of. So rather than, working on exponents or equations, something that we're a little bit more familiar with or have a better understanding, this might be a little bit different, and this might be something that you're going to need to maybe rewatch when you do your practice or when you do your assessment at the end of our unit, or this week's unit, that you know what you are doing, okay? So a lot of times, scientific notation, let's talk about it, what it looks like. We usually see something like this, where it is a number, in this case 4. 4 times 10 to the power of 3. A lot of times we will see this. Scientific notation helps us kind of make a more compact or a smaller number out of something, a number that is very large when we're talking about positive exponents in this case. And we'll get to the negative exponents in another video, but that's when the numbers are really small. So for people who might use these kinds of numbers, we're talking about maybe our microbiologists that have to measure sizes of cells, okay? We might be talking about aerospace engineers that must work with very large distances, such as light years, which we'll talk about in a little bit. So these numbers like this are very helpful when you're publicly showing numbers. A lot of times if you look at your prescribing information, there will sometimes be scientific notation, just because it's hard to write this large number without a bunch of zeros, okay? So when you do that, it makes a little bit more sense to those that need to know that specific great information or very small information. So the parts of this, so that first number that we always see, that's called a mantissa. I know that's a new word for us, but that is called the mantissa. We have our order of magnitude, which is typically our base of 10. I don't know that I've seen it anything other than 10, but probably some weird math does it somewhere. But typically we see it as a base 10. And then our exponent, technically it's called a characteristic. You will not see me calling it that very much, but if you hear it in other places, our characteristic is what we typically call our exponent. And before we move forward, there's a couple main rules that we need to talk about. For our mantissa, in true scientific notation, our mantissa can be 1, it can be 1.5, and it can go all the way up to 9.9999999. It cannot be 10. It cannot be 200. It will not be an appropriate scientific notation. So therefore, our mantissa must be 1 or greater, so it can be 1, but it has to be less than 10. It can't be 10, it's less than 10. And you're going to know what this means here in a few minutes. You do not just count the zeros when we are moving spaces around. So that'll become a little clearer when we talk about things. So let's take a look at this. Let's talk about larger numbers. All right. So here, I got to recount this. We have our hundreds, thousands, millions, billions. We have a number that's 35,400,000,000. That is that number. This one's a little bit easier. That one is 600,000. So if we get too much bigger than the billions, we get in trillions and quadrillions. It gets really hard to publish those big numbers because nobody's going to sit there and count those zeros and move things to the side. And those that really need to know those big or those really big or those really small numbers are going to take the time to do that. But it's easier to write it in scientific notation. And this is how we start. So the first thing that we need is our mantissa. So we have a mantissa. It's going to be times 10 to our characteristic or our exponent. So those are the two numbers I need. So I need to look at this and figure out where I'm going to get my mantissa from. So when I'm looking at this, I kind of work backwards. I pretend my decimal point's here, and then I move it over. So if I put my decimal point here, that gives me a 3.54000000. So that tells me that my mantissa can start here, but where does it stop? Because my mantissa, this 3, tells me that it is greater than 1 or greater, but less than 10. But I got to include this 5-4. So at this point, I'm thinking, okay, I have my decimal point here. I got to get rid of the zeros just temporarily, so I kind of cover them up. Whoop, or maybe not. And I see my, oh, it's hard to see because of the tilt. Then I have my 3.54. So my mantissa is 3.54. That is my mantissa. This number is 1 or greater, but less than 10. If you messed up and moved it over here and it was 35.4, that would be incorrect because that number is not less than 10. All right, so this is where our original decimal point was when we were determining our mantissa. So to figure out what our characteristic or our exponent is for this, I got to start where my original decimal point would be, okay? So remember, if this is a whole number, my original decimal point should be here. And then I just got to count how many spaces it takes for me to get to here to where my mantissa point is going to be, okay? So I just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So because I moved 10 places to get to my mantissa from my original decimal point, I get a 10. Okay, so this is in scientific notation now. These two numbers, okay, whether I use it in scientific notation or my standard form, both of these are equivalent to each other. They are the same thing. It's just way easier to recognize this if you're a scientist, what this is, rather than sitting there and counting zeros, especially if you're like Miss Pruitt and don't like to put commas, right? So for the next one, to get my mantissa times my magnitude of 10, and we don't know our characteristic. So I start over here to figure out my mantissa. I move it one place here, and I'm going to get just a plain old 6 because we have all of these zeros. So this one, my mantissa is just going to simply be 6, okay? My original decimal point, if we didn't have this mantissa, would be right here because it would be 600,000, and then we would have our zeros over here because we don't have any decimal parts of this. So I count how many places it takes me to get from my original to where my mantissa is. 1, 2, 3, 4, 5. So for this one, my characteristic or my exponent is 5. So 600,000, which maybe isn't such a ridiculous, we would probably write 600,000 if we were talking about money or what have you, or measurements, but in scientific form, these two mean the same thing. 6 to the power of 10 to the power of 5, all right? Times 10 to the 5th power. All right? So what happens when it's in reverse? So let's talk about that. All right, so this is when we have standard form to go into scientific notation. We can do it the other way. So you're looking at your medicine and it has some kind of weird measurements. Well, how big or how small is that? And you have it in scientific notation. All right, so we start with our mantissa. We have 3 34 hundredths times 10 to the power of 22. And for this one, this is how many water molecules are in a gram of water. Okay, yes, somebody actually did that. So I want to start kind of down here because if there's 22, there's going to be quite a bit of stuff going on here. So I'm going to write my mantissa. Okay. And because my number is getting bigger, I have to kind of move my work to the right. So I do this. Remember how I was counting, doing my little loop-de-loops with the other thing? This is what we do. We start here with our mantissa. Our number is getting bigger, so we're going to move our decimal to the right. So we are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. All right. So then I fill in my zeros. One, wherever I have a little indent is where I put my zeros. And technically I should have 20 of these. If you're a sloppy writer, I'll tell you another way that we can do this. Kind of how we get started. All right, I should have 20 zeros because I moved it, because if I had to move it 22 places, this decimal takes care of, or these, the 0.34 takes care of 2 of them, so I should have 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I do. So I can go ahead and erase this. Now I will give you guys bonus points if you figure out what to call this number. Okay? I'll have to look it up myself because it goes above and beyond. So let's see what we can do. So we have right here this 3. Whoop. There we go. We have our 3 here. Hundreds, thousands, millions, billions, trillions, quadrillions, quintillions. So I need to know what comes after that so then I can get rid of this. So this should be a 33. Then we have 4 followed by 20 zeros. Now seriously, who is going to write that in a newspaper or write-up when you can easily just write it like that? You might understand this number better, but when we have our scientists that need to know these large and small numbers, this makes just as much sense to them as this does, believe it or not. And it's easier for them to work with the scientific notation. So let's take a look at one that's going to be luckily a little smaller. So for this one, our mantissa is 4.5. So we go ahead and write that. And we need to move this decimal right here to the right 4 places. So I start here and I go 1, 2, 3, 4. And then I fill in my, wherever there's a dip, I fill in a 0. 1, 2, 3. So notice that this doesn't have 4 zeros. Okay, that's not what this means. This means I need to move my decimal that many places. And one of those places are when I move it to the other side of the 5. So that takes up 1 space. And then I have to fill in with the zeros, okay? So one of the biggest misconceptions that we talked about at the very beginning of this is it doesn't mean that we move or we have to put in that many zeros. This one up here only has 20 zeros, not 22 zeros, because we have this 3 and 4 that we had to move to, okay? Which means we fill in the rest. So this one, we moved it 1 to get the 5, so then we had to fill in that remainder of 3 with my zeros. So when I do this, it becomes 45,000. Okay, notice I'm getting rid of those old decimal points that we're working with, okay? You can sometimes enter these into a calculator as well. All right, so let me show you. Clear. So if I type in, let me show you what it looks like in a calculator. 33, 4, and now I'm going to type in 20 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Hopefully I did that correctly and I didn't like double count or skipped a count. So if we type in a big number and we hit the enter button, look at what we got. 3.34, and mine says, you can kind of maybe see it, it has the times x, or 10, sorry, times 10 to the power of 22, which is what we have here. Some of you guys will have it where it will say 3 and 3400ths, and they'll have an E in there, and then it says 22. Either way, that is how we can do it, okay? I don't know if it'll do it for a smaller number. Let's see. If I hit 45,000, let's see what it'll do. Nope, it'll just do that. So if the number is too big to display, it will give you the scientific notation. I think there are some modes that can switch between those with the smaller numbers, but most of your basic calculators do not, okay? Or there's some special mode, and then some math person will come in and tell me I'm totally wrong. So I want you to do 2 things. You're going to get practice writing 2 numbers in scientific notation, and and then writing them in standard form. So what I want you to do is, you can get your calculator to see if you're right, but not everything is going to show up there. So what you might need to do is you might need to pause and go back to points in my video to remember how to do this, because it's a lot of new information and it is not the most easiest thing to remember after being shown just twice. So go ahead, pause this video. I need you to write this in scientific notation, which means I need a mantissa, or a number that is 1 or greater but less than 10, times 10 to my exponent, or what we call our characteristic, which we will rarely call it that. So go ahead, pause this video, and see what you got. All right, so let's take a look at our answers. So for this represents the speed of light in miles per second. So light travels at 186,000 miles per second. So that is one of those aerospace Uber kind of notations that they may need to have written. So in order to get this, my mantissa is 1 86/100. It is greater than 1 or greater, but less than 10. So here is where my decimal point would be for that one. And then how much did I move to the right to get it to my original decimal? So 1, 2, 3, 4, 5, and that is where I got my 5 from. So for the mantissa for this one, okay, I'm going to have it right here, 5 and 8800ths. Remember, we dropped the zeros. Now if there's one where it was like 808, we have to include that 0 in the middle, but there isn't. Okay, so we stop there and we count. How many spaces did I move? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to get to my original decimal point, which means that my exponent or my characteristic is 12. Okay. Let's look at writing it in the reverse way, standard form. Okay, standard form. So we're writing it in our regular number notations. All right, so let's take a look at this. So once again, if you need to, go back in the video, follow along what I need to do. Remember, that's about writing that mantissa and moving that decimal point over however many spaces our exponent tells us to move over, okay? So go ahead and pause that video. All right, so this first number here, once again, I was talking about biologists. This number represents the number of red blood cells in the body, okay? And this one actually represents the approximate, well, at least when our original book was written, the approximate population of the United States. So let's take a look at this. All right, so we have 10 to the power of 13, which means my mantissa is my 2 5/10, so I had it here. So after I wrote my 2 5/10, I go ahead and move my decimal 13 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then I fill it in with the zeros. And then remember, if you're one of those people that leave those decimals, they will mark you incorrect on it if you leave that decimal there, because no matter how many times you have that zeros, it will still read as 2 5/10 rather than this large number. Let's see, hundreds, thousands, millions, billions, trillions. So it'll read 2.5 versus, how many did I say trillion? 25 trillion, hundreds, millions, billion, yeah, 25 trillion. So it would be like me asking you, do you want $2.50 in your bank account, or do you want $25 trillion in your bank account? I'm pretty sure I know what you would say. So there is a difference, so be careful with that. And then with our next one, the population of the approximate population of the United States. This is written there. So my mantissa of 3 and 2400ths, I would write it there, and I would have my decimal point. And then I would count 8 spaces to my right. So 1, 2, 3, 4, 5, 6, 7, 8. And we will get our 324 million people in the United States. And once again, if you leave that decimal there, it is wrong, so make sure that you adjust that accordingly. You probably will need maybe some additional practice. Reach out to us if you're still feeling a little bit iffy. Have a great day.